Hello students, welcome to VLearn. In this video, we will see chapter 3 metals and non-metals. This is a part 1 video. In this video, we will cover about the physical properties of metals. So in class 9, you have learnt about various elements. You have seen that elements can be classified as metals or non-metals on the basis of their properties. Think of some uses of metals and non-metals in your daily life. What properties do you think of while categorizing elements as metals or non-metals? How are these properties related to the uses of these metals? So in standard 9, you have already learnt about various elements in the periodic table, right? So we say some elements as metals and some as non-metals, right? So what are all the properties that actually, classify them into metals and non-metals? We will listen to that in this video. Okay. So we use some metals and some non-metals in our daily life, right? So there are some properties that characterize these elements into metals and non-metals, and we're going to see what are all the properties that actually characterize them. And we will also, what are all the uses of these elements which relate to the properties. We will have a detailed, look on it. So we know that always, the metals are classified and the elements are classified into metals and non-metals. And, the properties are classified into physical properties and chemical properties. This video we will cover about the physical properties. The next video we will see about its chemical properties. Okay. So the easiest way to start grouping substances is to compare their physical properties. So we will study about the physical properties of metal from activity 3.1 to 3.6. For that, you're asked to collect some metals for doing little experiments. So this is activity 3.1. Take samples of iron, copper, aluminum and magnesium. Note the appearance of each sample. So, when you see the appearance of metals, you can see that they always have a shining surface. Okay. So the next point, see, clean the surface of each sample by rubbing them with sandpaper and then note their appearance. So why you're asked to rub them using a sandpaper? Because, metals are highly reactive to moisture and atmospheric oxygen. They may form metal oxides. So the metal oxides can be deposited in their surface. To remove that metal oxides, you're asked to rub them using a sandpaper so that you can have a look into the metal surface. So the first property of a metal is they have a shining surface, that is called metallic luster. Okay. Next one is activity 3.2. Take small pieces of iron, copper, aluminum and magnesium. Try to cut these metals with a sharp knife and note your observations. What you will observe, you cannot cut the metals using knife. You just take an iron rod or else an iron nail, which will be available at your home. Try to cut it using a knife. For sure, you cannot do that. There is only one exception with this hardness of metal, that is sodium metal. Okay. Hold a piece of sodium metal with a pair of tongs. Caution, always handle sodium metal with care. Dry it by pressing between the folds of a filter paper. Put it in a watch glass and try to cut it with a knife. What do you observe? See, you can cut sodium metal because sodium is the only metal which that will be very softer in nature. So it can be easily cut using knife. Okay. And why it has to be handled with care? Because sodium is highly reactive with atmospheric oxygen and water. So it can easily form sodium hydrates and sodium hydroxides. Okay. The reaction between the sodium metal and water or else, oxides are highly exothermic. So they liberate large amount of heat which can even catch fire. Okay. So that's what the sodium metal always should be handled with care. Okay. So you will find the metals are generally hard. The hardness varies from metal to metal. Okay, the iron is the most strongest and hardest metal, and sodium is the softest metal. So from activity 3.1, we come to know that metals are lustrous in nature, and from activity 3.2, we know that metals are generally hard. Activity 3.3. Take pieces of iron, zinc, lead, and copper. Place any one metal on the block of iron and strike it 4 or 5 times with a hammer. What do you observe? Repeat with other metals. Record the changes in the shape of these metals. So why you have to, you have to place one metals on the block of iron? As I already told, iron is the most hardest metal. That's what we are doing it with the block of iron. Okay, so you're asked to strike them, isn't it? What will happen when we strike the metals 4 or 5 times with a hammer? It will change its shape. Okay, so the chain, it can easily change its shape from one to other. That is called malleability. Okay, so metals are highly malleable in nature, and you will find that some metals can be beaten into thin sheets. Have you come across aluminum foil for food? For food parceling and all, actually people will use aluminum foil sheets. Okay, so it can be made into very thin sheets, and it can even transform heat. It can even, heat can be holded inside the aluminum foil itself. That's what we aluminum is a metal, right? That's what it can be easily made into thin sheets. So we will use aluminum foil sheets for food packing and all. So the property of forming different varieties of shape is called malleability. See, the gold and silver are highly malleable metals. We make so many ornaments with different shapes. Next one is activity 3.4. Consider some metals such as iron, copper, aluminium, lead, etc. Which of the above metals are also available in the form of wire? Okay, so we use copper wires in our cable connections and all the chargers and all. Inside the there will be a rubber layer. If you cut them and see, you can see copper wires inside the charger cable, because the metals or they are actually good conductors of electricity, and they can be even drawn into thin wires easily. Okay, so the ability of metals to be drawn into thin wires is called ductility. Okay, gold is the most ductile metal. You will be surprised to know that if you take 1 gram of gold and if you make it into a thin wire, means you can make wire up to 2 kilometer length. This is because they are highly malleable and ductile. That's what we can even make it into different shapes and use it for making ornaments and all. Next one is activity 3.5. So can you, have you ever wondered why do we cook in vessels which is made up of metals? The reason is because it is a good conductor of heat. Okay, that's the reason. See, activity 3.5. Take an aluminum or copper wire, clamp this wire on a stand as shown in figure. Fix a pin to the free hand of the wire using wax. Heat the wire with a spirit lamp, candle, or a burner near the place where it is clamped. What do you observe after some time? Note your observations. Does the metal wire melt? See here, this is a stand and you have to clamp a metal wire. This is a metal wire. It has been clamped here. And to the free end of the wire, you're asked to fix a pin using wax. So this yellow color is a wax and this is a pin. And near that you have to, you have to switch on the burner. Once the burner starts burning, the heat is transformed from here to here. And because of this transformation of heat, the wax melts and the pin will automatically falls down. Okay, that will be your observation. See, after some time, the copper and aluminum wire will begin to eat up and expand due to the heat from the burner. If the gas gets high enough, the wax used to secure the pin on the wire may melt and the pin may fall off. So the above activity shows that the metals are good conductors of heat and have high melting point. See, only the wax melts, but the iron, but the metal wire will not melt because it has a high melting point. Too much of temperature has to be applied to melt a wire. Okay, so it's a good conductor of heat. Next one is activity 3.6. See, set up an electric circuit. Place the metal to be tested in the circuit between terminals A and B. Does the bulb glow? So this is a electric circuit, and between A and B you have to connect a metal, and once you switch on the circuit, see the electric current from here, from the battery, it will reach point A, and through the metal it can reach point B. and it can easily, the electric current can easily reach the bulb and the bulb will glow off. Okay, so it is because, it is because of the physical property of metals that it is a good conductor of electricity. Thus it can conduct electricity from point A to point B. Thus the bulb can can glow. Another thing is, um, see, you must have seen that, wires are usually coated with polyvinyl chloride or a rubber-like materials. Okay, because metals are good conductors of electricity. If it is not coated with this polyvinyl chloride or else rubber-like materials, means if you touch the copper or copper foil or else a copper wire, you can easily met with the electric shock. That's what it has been covered. Polyvinyl chloride or rubber like materials will not conduct electricity. That's what we are coating it with, coating the metals with um, polyvinyl chloride or rubber like materials. So what will happen when metals are strike to your hard surface? If you strike the metals with a hard surface, it will produce sound, right? That nature is called sonorous. Okay, that is what our school bells are even made up of metals. So this is a simple recap about the physical properties of metals. So metals are highly luster in nature. They are hard, they are malleable, ductile, and good conductors of heat and electricity. So please like my video, share my video, and subscribe my channel, children. Thank you so much for your support.